Hello, everyone, and welcome again to my session. Today's session titled Machine Learning Basic Tools Introduction to Seaborn. Well, Seaborn is a continuation of our data visualization libraries. Previously, we had discussed Matplotlib, another data visualization tool. Before that, we covered NumPy and Pandas. So, in continuation of that, today is Seaborn. So let's get to it, shall we? Okay. First of all, what is Seaborn? What is Seaborn? Well, Seaborn is a data visualization library, okay, in Python. It is built on Matplotlib, okay? Matplotlib. But why Seaborn? Why should we use Seaborn? Yesterday we had discussed about Matplotlib, a data visualization library, and we called it the grandfather of data visualization in Python. But now why Seaborn? First thing is, it is easier. There were some complexities in Matplotlib, so there were some software engineers, some developers who worked on Matplotlib and added their skills, added their knowledge, and manipulated Matplotlib, created functions, and ultimately created Seaborn in order to make the thing easier. Another thing is it is aesthetic, you know. The graphs, the plots that you're gonna see here are in comparison are a bit more aesthetic, better looking graphs and plots. Okay. Third thing is it is really popular, and you will be seeing that people use Seaborn really most often. I think it is even more than Matplotlib. Matplotlib is a must, but Seaborn is also used for its easiness and aesthetic views. Okay, and for its popularity, you can kind of say that Matplotlib goes in the back a bit. Okay, that's why we use Seaborn. Not only that, there are also lots of different types of plots we can make in Seaborn. Okay, fine. But what is the discussion point for today? What type of plots can we build? What type of plots can we make in Seaborn? Let's discuss that. Types of plots. Well, you can do lots of stuffs in it, but mostly we're gonna cover these types. First one is relational plot. Relational plots or graphs, diagrams, whatever you want to say. Second one is distribution plot. Distribution plots. Third is categorical plots. Categorical plots. The fourth is matrices. Okay, matrix plot. And the fifth is regression plot. Okay, these are the main types of plots in Seaborn. Now you might ask, why should I believe you? Well, you don't have to believe me. Let's see the documentation itself. I've opened up the Seaborn API, and here if you go to the function interface, you'll find the plots. Relational plots, then you have distribution plots, then below that you have categorical plots, then you have regression plots, and finally you have something called matrix plots as well. You can also do some multi-plot grids. We'll come to that part later on. Clear? Okay. But which is for what? Okay. Why do we use these relational, distribution, categorical, matrix, or even regression plots for? Why you use them for? Well, in a vague sense and in an overview, you can say we plot relational plots for making relations, understanding the relations between data points, especially numerical data points. In distribution, we use them to understand the range or the distribution, you can say, of the data points, how they are behaving. Okay, fine. For categorical, the same thing, their behavior, their count, behavior, or count, anything. Especially the count part. When we are dealing with categorical data, we must know how many categories are there and how many numbers are in each categories. Okay, it's a must, and we can find that by using categorical plots. Then you have matrix plot. Matrix plot is basically used to find the correlation, or you can say the to visualize the correlation. Correlation. Clear? Between different features, that is columns. And finally, the regression plot is used for basically regression. In machine learning, regression. If you had attended or saw my videos, my session on machine learning simplest understanding, I have talked about regression. I have discussed what is regression in machine learning. Okay, it is a kind of an algorithm that deals with numerical data to predict. Okay, I will discuss a bit in this session as well. Okay, so fine. We have found out that types of data, these 5, and we have found out what are they used for. Okay, now which plots can we build up? Okay, we have seen in the API, but still let's go one by one. Okay, in relational data we can do something called scatter plot or something called line plot. We can also use something called rel plot. In distribution we can do count plot, we can do bar plot. Okay, we can do histograms, hist plot. We can also do something itself, naming distribution plot, that is dist plot, and finally dis plot. Okay, let me zoom out a little bit. In categorical, oh, I've mentioned these things are for categorical. Okay, so let me remove this into this part. For distribution, you have something called KDE plots. Okay, there's other kinds of plots. Let me see the API. Okay, let us see the API here. For distribution, you have this plot, his plot, KDE plots, RAT plot. Yeah, I have. Okay, I was correct. These plots are for distribution, for categorical, but not the count part. Count plot is for the categorical part. Okay, count plot. There's something called box plot. There's something called violin plot and others in the API mentioned. You can find it here. Okay, there's a special plot called cat plot. Let's also discuss this. We're gonna discuss tree plot as well, swarm plot, and cat plot. Okay, in matrices, for correlation we will be discussing heat map. Okay, and for regression we'll be discussing LM plot, that is line plot, or you can say a rag plot. So this is the agenda for today. If you zoom it out, then you can see there's tons of graphs and plots we are going to be discussing today. Tons of graphs. I think it might be 10 to 12 plots. Okay, so let's not delay. Let's get straight to our Jupyter notebook. Okay. Now, first, if you want to work in Jupyter, work with Seaborn, you have to import that. But before that, we also have to import our main libraries. Okay, which are the our main libraries? Let me zoom out a little bit. Which are the main libraries? The main libraries are firstly NumPy as NP, Pandas as PD, then you have Matplotlib. Although we are not going to use Matplotlib, but still it's a convention. Matplotlib.pyplot as PLT. Then you're going to import our Seaborn as SNS. Okay, the aliases are your choice, but SNS and PPD are the tradition or convention. Okay, so let's run. Okay, oh, Matplotlib, I missed a B here. Let's run it again. Yeah, fine. See that? Okay, now let's work. But where are we gonna work? What is the data set we are gonna work on? We can also find a data set by using Seaborn. Let's install a data set called tips. How we gonna do that? We're gonna use a function called load underscore data set, and here we're gonna mention our data set name that's called tips. Let's print it. Let's see what prints. See this? Okay, fine. Now you might be asking, where did I get that? Again, the answer is the API. Go to API. In the very below part, there is something called load dataset. Click on that. It will guide you to a GitHub repository where you can find all the names of the dataset that is present in Seaborn. Okay, below that there's dots, there's flight, iris, very famous CSP5. Okay, you just type in the name and it will automatically load in Seaborn. Got that? Okay, let's continue. Now the first topic for today's discussion is the relational plots, and first of all we are going to discuss scatter plots. How we are going to make a scatter plot? It is sns.scatter. Well, it is not scatter. In Seaborn, you have to mention scatter plot. Mind it. Many times you're gonna see that you are doing everything right, but you have mistaken a single word or letter maybe. Okay. Be very careful about these things. Okay. Now what we are gonna do now? Our key magic command, that is Shift Tab in Jupyter, and see all the doc strings. Okay, there's X, there's gonna be Y. Okay, let's put in our X and Y, the X value. Before that, let me do another thing. Okay, before that, let me check all the column names so that I don't mess up. Okay, fine. So we got all the columns name of our tips data set. Let's use for X, we are gonna use, let's say, what? Let's use total bill. Total bill. Fine. For Y, for the Y axis, let's gonna use tip itself, and the data set is tips. Clear? Let's run it, and you can see there's a beautiful graph, a scatter plot. Let's zoom out a little bit. See this? It is our plot, scatter plot. Clear? You just have to know the function and then just go through the docstring, what are the parameters, and according to the docstring, according to the parameter, write your parameters, and you'll be able to create a scatter plot like this. Fine? Okay. Now, for further knowledge, what else can we do? We can do something here that we couldn't do in Matplotlib, is this. See this? At the same time, in the same graph, we are able to print out or get a table, a plot related to total bills, tips, and also the sex feature. The orange dots are representing female, and the blue dots are representing the male. Okay? Not only that, we can do further. We have another parameter called style. Let's do style for day. We can add another parameter. Let's see. See this? See this on the legend? The legend is also automatically created. For Thursday it's going to be circle, for Friday it's a cross, for Saturday it's a square, and for Sunday it's a plus sign. Is it clear? We are not going to stop here. There's another thing you can do. More. There's another parameter called size, which will indicate how much numerical values are in each point. So here we can use size feature. Let's see. It will print in a bit. Yes. It is indicating the more the value, the greater the circle or the icons you're going to be using. See, in the legend, it is clearly mentioned. How cool is that? You couldn't do this thing in Matplotlib. Or if you could do something like this or other stuffs, it will be really complex for you to do. But in Matplotlib, in Seaborn, you can do it really easily, and the graph is also looking nice. It's a nicer looking graph. Fine? Okay, let's do the same thing and create another plot called line plot. Line plot. The parameters are also the same. It's going to be total bill. Let's do y tips, and for data we're going to be using our data that is tips. I think the tips doesn't have an s. Let's remove it and run it. Let's see. Yeah, here you go. You understand what happened here? You understand? It basically connected the dots. Let me show you. It did nothing, just connected the dots. Like this, you have this point, this point, this point, and this point. It basically connected this, then this, then this. Okay? Nothing else. Clear? Okay, fine. But can we do the same thing here like we did here? All the parameters changed. Let's see if we can do that also. Let's copy everything, go to the next cell, cover everything and paste it, then run. And guess what? You can do everything that you could do in the scatter plot here also. It just connecting the dots, and you can here also use hue, styles, and size as well. How cool is that? In one graph, in one plot, you are able to use, I think, 4 to 5 features at once. Okay? Amazing. Okay. Now I'm going to talk about another function, another plotting function that you can use. It's called sns.relplot. Now, before going to that, let me discuss another thing in Seaborn. In Seaborn, you have something called, you can plot two types of plot. The functions, the plotting functions are of two types. First one is figure, and another is normal. Say normal. Okay. Some functions are figure functions, and what they do in this type of functions, you use the same name, like suppose it is plot, and in a parameter you're just gonna mention the kind. If it is scatter, you're gonna mention the scatter. If it is line, you're just gonna mention line, and it will print the whole thing. You don't have to remember all the functions. You just need to tweak in the kind parameter and it will print. Let's see how. Let's see. I have told you it is our figure function. So first let's see the docstring as well for our convenience. Here you will see and understand what I meant. Okay. Here you can see X, Y, and here at a bit down you will see this kind. Okay, you can use, by default it is scatter, you can also use line plot. Okay, so let's see that since it is a figure function, for we can do the same stuff as scatter and line plot. We don't have to remember scatter and line plot separately. If we just remember rel plot, we will be okay. Okay, just mention the kind here at the last. Kind equals, suppose, scatter. See this? The graph is a bit tightened, but it is the same graph as it is. Okay, same graph. Okay, there's no axis on the right portion, but it is the exact same graph. You can do line plot without changing anything. Just mention line plot or line. Let's see if it is line or line plot. I think it is line. Okay, let's run this. Let's wait a bit. And here, exactly the same plot, exactly the same thing. Fine. Okay, so by far what we have learned about scatter plot, we have learned about line plot. Okay, and you can do the same functionalities using rel plot. These are relational functions. Clear? It is basically relating x and y. Okay, let's go to next topic. The next topic of discussion is basically the distribution plots. Okay, among distribution plots, let me go through the API a bit. Okay, where's the API? Here. Let's go back. And you will find the API here. Let's again refresh it. Yeah. Okay, we are here. Let's go to function interface, and you're gonna see relational plots. We have covered rel plot, scatter plot, and line plot, and you can see figure level interface. As I have mentioned a bit earlier, it is figure level interface or figure level function. Clear? Okay. Now we are moving on to distribution plots, and in distribution plots you can plot this type of graphs or diagrams. Let's do this. Okay. And another thing, guys, if you feel stuck, if you want to know more, you know, in a session I can't cover everything related to a function or every function in Seaborn, every feature of Seaborn. In the left side you can see there's so much things we can do here. Okay, but I'm giving you a basic idea. If you want to learn more, if you want to know more, increase your knowledge, increase your practice, go through the documentation a little bit. Okay, it is a really good advice and it is the best resource that you have. Okay, fine. Let's do the first thing. Let's do a dist plot, shall we? sns.distplot, see the doc string. Okay, since it is only taking one parameter, you see there's no xy, it is only a. Okay, it will mention the range of our entire thing. So let's see the range of total bills. There's total bills. Let's see if it runs. There's an error because here there's nothing called data. So I have to mention where the total bill is taken from. It is taken from the data set called tips. Let's run it now and it printed. Okay, it looks like this. Clear? Amazing. Okay, we can also tweak in a bit. You see this blue line, a curve, it is called KDE, kernel distribution something. Okay, or kernel distribution estimator, perhaps. Okay, it tells you how your data is distributed. By looking at this graph, you can easily find out that from 10 to 20 or 12 to 20, the values are maximum and it gradually declined as you went right. Okay, if you want, you can tweak a little bit. How? Let's see the distribution. You can remove the histograms as well. See this? Hist is true and KD is true. You can false them. That's false one. Let's false the hist. False. Let's print it. The histogram is removed. Clear? Fine. Let's plot another thing, shall we? We have printed this plot. Let us print hist plot. The same thing. Okay, let me remove this hist plot. Got this? It is giving us a histogram. By looking at this, you can also see that the maximum values are in between the range of 10 to 20, and after that it gradually declined. You get an idea, you get an impression and analysis, everything regarding your data set. Clear? Okay, let's do another plot. What else can we do here? Let's see. We can do KDE. Okay, previously in this plot we did KDE and his plot together. Now we did his plot only. Let's do KDE only. Kernel distribution estimator. See this? Okay, fine. Okay, what else? Rug plot. Now rug plot is something like a barcode, if I'm not wrong. Let's print it. At the very bottom you see this, it is mentioning how the distribution is. You see it is dense here in between 10 to 20, and then later on it is really not so much dense. So you get an idea of the data set from this. Clear? Okay. Now, like the relational functions, there is also a figure level function. Let me show you the API. Where's the API? Wait, yeah, it is called this. You see, figure level interface. Let's go to the API and let's have a look at this. Okay, here it is clearly mentioned the kind parameter selects the approach to use, and you can use kind equals to hist for your hist plot, kind equals to KDE for KDE plot, and ECDF for ECDF plot. Okay, and you can find out how all of this plot looks like with examples in the API. See this? Here the kind is KDE, here the kind is hist. This is called a ECDF plot. This is our this plot previously. Okay, you can do this also. Okay, fine. This type of plots also fine. Just have a look at the API, the reference, the documentation, and you'll find lots of new stuff. Okay, just explore a little bit. Okay, fine. Okay, let's do the this plot ourselves, shall we? Let's do this. It is not dist, it is only this. And here you have to mention the parameter called kind. Let's do a hist plot. Hist and run it. Here we have our hist plot. So in like this, similar to the relational functions, we have something called figure level interface functions, where we don't have to remember all of the other functions. We just need to remember the figure level interface functions, and we can plot any function. Just have to tweak in the kind parameter. Clear? Clear. Let's see what else we have remaining. Let's see. Okay, let's go back. So we have discussed relational plots, we have discussed distribution plots. Let's go to categorical plots. Okay. Okay, categorical plots obviously is going to introduce, it's going to tackle categorical data. Let's print our tips columns again for our reference. Here it is. Let's go to the new cell and let's plot count plot. So by the name itself, you guessed it, that it will count. If you want to look at the docstring, you can also look at it. Shift plus tab. Okay. Here you see you can use X, Y. You can also here use hue. Let's use that. Okay. Here you have also mentioned the data, also orientation. Let's also do some tweaking here too. Okay. First we need to mention the X. In X, let's say it is what? Suppose it is day. Okay, we are covering day. It's a categorical data since it is Thursday, Friday. It is no numerical. And another let's first do this. Let's see if it prints data. Let's mention the data. Let's see if that prints. Guess what it printed? It only showed you the counts. Okay, at Thursday, the total count, the people related to Thursday went to the what? Went to the bar and gave tips. At Thursday is 60, at Friday it's close to 20, at Saturday it's booming high above 80, and at Sunday it is almost close to 80. Okay, okay, fine. If you want to see how many males and females. Let's do change the feature, and you will be able to see how many males and females are there. Clear? Going to the bar or restaurant. Clear? Okay. Let's go and do X and Y now. X and Y. And a really interesting thing is that by using just X, you get the count plot of your categorical feature. And you can do X and Y, and in Y portion, you can include a numerical value as well. Let's see that. Let's see day, and in Y we want to print at each day how much tip is paid. Okay, how much tip is paid. Okay, what's wrong here? Tips, I guess tips. No, what is the wrong? Can't pass values for both. Okay, let's see the doc string whether we have made any mistakes or not. Here it is Y. Okay, it is mentioned, so why is it running? Let's change it to say smoker. Let's see if this time runs. Okay. Okay, then let's go to the documentation. If you're having a bit trouble, let's go to the documentation. No problem. We are gonna find count plot at the very bottom. Let's go there. Here you can see we can use X and Y. Okay. I have something logical error or something. That's why it is not printing for me. No problem. We're gonna see it here. You see this? It has taken a data set called Titanic and only used X portion. Only used X portion and found out the count number. Okay, let's see if they used Y somewhere. Let's see that. Oh, that they didn't use Y. Okay, okay. Okay, let's see that. Let me tweak in a bit more. Oh, in the Y portion it goes to, I think it should be a numerical value. Okay, it's still giving me error. Okay, fine. Okay, I think you can't use that. Okay, guys, see the documentation a bit. I think there's a bit of problem, but in docstring we can see you can use Y. Okay, 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 we'll figure it out. But let's use hue. Let's use hue. If you wanted to do this thing in matplotlib, you can't do it in one function. Okay, you have to manually tweak in, manually do stuffs if you want to make this, and it will be a code of 6 to 10 lines of code. Okay, for the same thing. But here you can just put in the hue value, hue parameter, and you will get it. It is saying, giving me a plot related to how many male and female are going to the restaurant at different days of the week. At Thursday you can see the female number is higher. At Friday you can see the male number is higher, and the Saturday and Sunday the male proportion is almost the double rather than the female portion. I guess at Sundays you have a holiday or something. That's why the people go out, right? You can make an assessment of that. Okay, fine. We have created a count plot. Can we create something else? Let's create something else. Okay, let's create something called box plot. Let's remove the hue for convenience. Okay, what is it now? Horizontal. Okay, okay, let's see the data. Doc string x y hue data, everything's fine. Okay, let's use here total bills. Total bills. Box plot is kind of a mathematical graph, guys. Okay, that's why it is giving me an error. Box plot is kind of a mathematical error, and I think previously if we had something like this, let's see count plot. If we do total bills here and do y for say sex, then do data equals tips. Let's see if it runs now. Okay, it's still giving me an error. Okay, okay, you guys see that in the documentation, please. Okay, let's not waste too much time here. So what is box plot? You will be a bit shocked, like what is this, what kind of plot is this? But it is a mathematical plot and it tells you lots of stuff. what it tells you? Let's find out. Let's Google it. Let's type in box plot details. Let's see what does it give us. Okay, let's go to the images. Let's pick an image. Okay, this one. Let's copy it. Let's print it in our notebook. Okay, it's taking a bit time. uh, okay, okay, but let me open it in new tab. Hopefully it will open. Yeah, here you can see in the okay, here you can see in the picture that in a box plot the leftmost line indicates something called quartile and IQR. Okay, IQR is interquartile range. It is something related to statistics. Okay, just remember this, it is a kind of a mathematical plot that gives you an idea of the whole feature or data set in a graph. It tells you lots of things. Okay, here you can see, let's see if it printed. Okay, we got here. Okay, okay, fine. Here you can see that from this very graph there we can find something called minimum. There's something called interquartile range. We can find the median also, we can find the maximum values, and we can have an idea that how many outliers are there in my data set. Okay, up until this position you can see 25th percentile. It tells you up until this position this is the 25th percent of the whole data that you have presented in the function. Up until this line it is 75 percentile data. Okay, so by assuming this, by seeing this, you can understand there's lots of mathematics going on in box plot, right? Okay, I'm not going in too deep here. Okay, but for your, just to make you understand what is box plot, basically it is a mathematical plot that gives us lots of idea about the feature. Okay, fine. And here in the picture you can see as well, it is giving us lots of parameters, the outliers. We can have an idea of the outliers, we can have an idea of the median and the max and minimum values, etc. Clear? Okay, okay, fine. Let's go back to our notebook. So we have created something called box plot. We can also create something called violin plot, and it is also something related to math. Okay, it is weird, right? Yeah. What do you understand by this? Again, it is a mathematical type of function and it tells us lots of information. But now we are not going deep in the plots. Why? What is it telling us? Just I'm showing you how can we create this. Okay, what else remaining in our categorical plots? Let's see. We have printed box plot, we have printed violin plot, strip plot, and swarm plot. Let's show you this two also. Let's see strip plot, something called strip plot. Here it printed. Okay, this is called strip plot. Okay, okay, let's see if we can find input a y value here. Let's see that if it runs. Previously it didn't run for some reason. Now it ran. Okay, now it ran, and here clearly what is it telling us? It is telling us that how many smokers are there. The blue is representing the person is smoker, and the no portion is telling us that no, it is not a smoker. And in the x-axis we are seeing the total bills. So obviously it is saying that from 10 to 20 in the orange part, the total bill range 10 to 20, non-smokers gave the most. Okay, and the maximum value here in comparison of the two data set, here is a blue dot. It is the maximum. I think it is close above 50, and it was also given by a smoker. Okay, so like this you can make analysis of the data set by seeing different kinds of plots. Okay, what else we are remaining? Let's see swarm plot. Let's see swarm plot, and let's change the parameters a bit. Swarm plot. Okay, there's something wrong here. Okay, wait. Let me copy the whole thing. Let's print it. Okay, I'm having a bit trouble with the mouse. Yeah, it's correct. Okay, fine. Swarm swarm plot, wait. Plot x value equals to total bills. Okay, let's see this. What's the error? The error is total bills. Could not interpret input total bills, so it won't be a total bills here. Let's remove the y portion and let's run it. Okay, categorical data, let's input sex and let's run. It should run now because we previously inputted the numerical portion. So here you can see a swarm plot. Okay, okay, fine. So what else remaining? Okay, let's discuss one more categorical function for plotting. It is called cat plot and it is a figure level interface. What else figure level interface function have I mentioned earlier? Can you remember that? Well, let me tell you. For relational functions or plotting, we have mentioned something called rel plot. For distribution, let me say dist, we mentioned something called dis plot. And now for categorical, we have something called cat plot. All of these three are figure level functions. By tweaking in one parameter called kind, we can make different kinds of plots regarding each of our type. Clear? So let's use cat here for categorical plots. Okay, let's copy. Okay, let's change here. Let's change it here. Let's say cat plot. Cat plot. Let's change this to, let's say, what, smoker, and you get an idea. Okay, what is the kind? Let's change the kind. Let's change the kind. Okay, there's a parameter called kind. Let me show you in the docstring, whole docstring. If you go below, you will find something called kind, and by default it is put it in strip plot. That's why it is giving me a strip plot. Okay, and again another thing, guys, here you can see lots of parameters, okay, to tweak in the function. Okay, lots of parameters. Have a little bit of exploration, change this and that a bit, and you will see how beautiful you can make your graph look. Okay, fine. So let's change our kind to, let's say I want to make a count plot. Let's say count, and we have a count plot. Just changing the kind, we can make it a box plot. Let's see. Okay, box plot is gonna give me an error, numerical value. Let's print what? Let's print a swarm plot maybe. Let's see. It's taking a bit time, and here we have a swarm plot. Clear? So by using one function, we can make different kinds of categorical plots. So let's see what are other functions can we make. I'm not going each and every one. Okay, let's see the documentation of cat plot. Here you can see that we can use kind equals to strip for strip plot, swarm for swarm plot, box for box plot, violin for violin plot, and etc. And in the bottom you can find different examples as well. Okay, examples. Okay, Okay, fine. So let us see another thing. Let us also explore a bit box plot since we made a bit of mistake. Let's see if we can find out what is the mistake. Shall we? So here we are seeing that a box plot shows the distribution of quantitative data, not qualitative data that I have previously mistaken. Quantitative data, that means you can uh, quantify, that is numbers. Previously I inputted sex and smokers, this or days. These things are what? Qualitative data, or you can say categorical data. So it won't work, and that's why we got an error. Clear? Okay, below that we can find examples. Age is a number. Okay, that's why it is printing age. Okay, it is a quantitative data. Got the box plot? Okay, so what's the next plan for us? What else? So we are done with these things. What things? Let's see. We are done with relational plots, distribution plot, and categorical plot. And now it's time for a really amazing and good looking plot called matrix. Okay, let's talk about that. Let's create a new cell. Okay. Another thing, let's invite a new data set, shall we? We can do that. And the name of the data set is flights. SNS, remember the function load underscore data set. After writing a bit, you can put in tab and it will automatically complete the rest of the part. The name is flights. I have shown you all the data set name. Where can you find it? Everything in the first part of my lecture. Let's print the flights data set. And here is our flights data set. Okay, let's see the only columns. Wait, let only see the columns. Flights dot columns. There's only 3 columns, don't need it for that, but still. Okay, now let's see. We'll work with both. Okay, we'll work with both. First of all, let's work with tips. Now let me introduce to you with a new function called core. What does this do? Well, it gives you the correlation between different features. Let me explain this part a little bit. What does this mean? Now, in a data, suppose you have 3 features. What are the features? The columns, like X column, Y column, and Z column. These are called features. Features. The correlation basically means how much is the data set features are related to one another. That is, what is the relation between X versus Y, X versus Z, Y versus Z, or it might be, let's say, Y versus X, etc. Okay, what is the relation between these versuses? Okay, and we can get that by using a simple function called core. It gives us value from 0 to 1. I think it also gives negative values. Okay, let's see if there's any negative value, but it will give negative value. Let me explain this. If the correlation is equals to 1, then this means that our 2 features, feature 1 and feature 2, are exactly the same. Okay, because it is 1, correlation is equals to 1, that means it is exactly the same. It is what it is. Okay, so we can say feature 1, if it is X, then it is also X. Got this part? The lower you go, the closer to 0. Let's see, how can we say this? The closer to 0, the closer to 0 you get, the relation is so downwards. Okay, it means that it is not relating too much. There's too much difference in these two features. The more closer to you get to 1, okay, the relation is upwards, that these two features are quite relatable. Clear? I hope so. Okay, I hope so. And if it is 1, then the features are exactly the same, and if it is 0, then there's not a single data point that can be related to one another. Now what about the signs? If it is plus, that means if x grows, the y feature also grows, that means increases. If the correlation value is negative, then if x grows, the y decreases. In this case, the graph is supposedly going up, and in this case, the graph is going downwards. I think I'm clear on the correlation. This is what correlation tells us. See, one value, total bill is total bill, so it is exactly 1. Okay, and if you just investigate on the data a bit, you will see that the data points, it is in between the range of 0 to 1, but it can be negative if it is what? If it is a negative correlation. One increases, the other decreases. Now the thing is, seeing this data, it is really not pleasant to our eyes, is it? So much data points. It will be really easy if we could visualize that, and we can do that in SNS by using heat map. It is a matrix plot. Let's use, we have to input the correlation. Remember that we have to input the correlation first, only then we are going to get a heat map. Let's run this. Tips, okay, okay, S. Let's run this, and here you have a heat map. Fine, amazing, right? By looking at the rightmost part, the line that is indicating what the colors mean, we can easily find out the relation between each feature. If it is totally white, as we can see in the right part, it is 1, and it is actually 1 here, cause total bill is total bill. Clear? Let me show you if you still didn't understand. In the x-axis you have y, and here you have y. So it is representing these things. Sorry, let me go a bit. So it is representing the column, and this is representing the row. Okay, so what row and what column? This column and exactly this row, both are representing this cell. Clear? That's why the both values are the same, the exact, and that is why we are having a correlation of 1. In the color map we are having white, but it need not to be necessarily be white. We can change the color. You might ask how? There's a parameter called CMap. There's other parameters, tweak in a bit. We can change it to Veridis, something called Veridis. Let's see this now, and it changed color. How amazing is that? Okay, fine. Now let's do something else. Let's do something called magma. Okay, and it changed as well. Like this, it is a matrix like plot, that's why it's called matrix plot, and by using matrix plot you can find the correlation between features. Clear? Let us give a broader example. Okay, we can do something called pivot table as well. Flights dot pivot. We are using flight now. Table. Let's see if it prints. There's some values you need to be inputted. Okay, values. What values? Indexes and what? Columns, indexes. Let us give the value of flights. Let us give the indexes. What? What were the columns of flights? Let's see, the columns be year and the indexes be passengers. Okay, let's input. passenger, passengers, and column equals to year. Let's see if I have any spelling mistake. Passengers here. Okay, let's see if it runs. Let's see that. Okay, there's nothing called call. Why? Columns. Columns. So do columns again. Okay, we're having a bit trouble. If we are having trouble, what can we do, guys? We can see docstring, we can see documentation, and we can use Microsoft Copilot as well. Let's use that. Let's copy it. Let's use it, Copilot. Let's see what's the correct code it gives us. Let's see. Let's wait a bit. Don't worry if it gives you wrong answer. I also have the solution for it. Don't worry. Let's see what it tells us. It has given us the code. Fine. Let's copy it. We only need this part. And paste. Let's see what happens. Still giving us error. So, some other column. Okay. Since we are having a bit trouble in finding the plots, I already have the plot here somewhere. Let me show you that. Let's not go too much, waste too much time. Let me show you this. I already have collected data regarding flights. Okay, regarding flights. Okay, here's the mistake that I made. Let's then copy this one. Okay, let's copy this one and use it in our values. And let's see if it prints. Yes, this time it is correct. Let's call it PV or PT. Too much writing. PT. Okay, PT and print. Boom. Now you have a matrix like structure representing the column. There's year. In the months you have the index, and in the values you have passengers. Okay, it is giving a matrix like information. Amazing, right? We can have three things at one plot and numerically, but can we make it a heat map? Yes, we can make it in heat map. Let's see that. sns.heatmap. As I mentioned previously, we have to mention the correlation, and pivot table is giving us the correlation, so we can input the PT and see the plot. Here you go. Amazing plot, right? How cool that looks. Let me tweak in a bit. Let me tweak in a bit, like line width. Line width, okay, equals to like 1. Let's do it again. Let's see what changes it makes. Wow, it looks better, right? Yeah, like this you can have lots of tweaking. Just go to documentation, or let us see the doc string. All the parameters you can tweak in are well organized and well documented here. Fine, fine. So it was about the matrix plot. One more type of plot remaining to be discussed. Okay, that is, let's go to our notebook. Let's see. And it is something called regression plot. Something called regression plot. See this? Now I have previously told you that regression plot is going to be used in something called regression in machine learning. And I have discussed this thing in my first session regarding machine learning simplest understanding. But here also let me give you a quick recap. What is it? In regression, what happens? You have a line like this, a plot, right? You have a data points like this. Lots of data points, lots of data points. What machine learning algorithm does is that it somehow finds the best line here. Which line? Is it this? 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 Basically, it finds out the best line possible so that it can represent the whole data, minimizing the losses. The minimum loss possible, the best line to cover all the data set, it finds out. And this blue line is the best line that you can find. The algorithm works like that to find out the best possible line representing your whole data set. If it was like this, would it represent the whole data set? Obviously not. All the data set are above itself. If it was like this, will it represent? No, most part are below. So it will be it in something between to have the minimum loss. Okay, so this is the line our LM plot automatically figures out from our data set. Clear? Okay, let's see that. Let's create a new cell. Let's tweak in. Okay, let's, which one? sns.lm plot. Let's cover total bills or passengers. Let's see if passengers work. Passengers will work. Yes, it is numerical, so it will work. No problem. Let's see passengers. Passengers. Okay, will I have to type in the data? I think I'll have to mention the data. Yes, I have to mention Y as well. So what should be the Y portion? Let's see. It is also correlating. Okay, let me tell you this stuff as well. It is basically there's a X value here and Y value here. What are these data set meaning? These data set are representing the relation between X and Y. All the data points are basically X comma Y, right? It is a kind of a relation, and our algorithm or LM plot is basically finding the best possible line to represent all the data set. Okay, clear. So let's have in Y portion, what can we have? Another numerical value. What is the numerical value here? Oh, there's not much numerical value. So let's go with our tips part. Okay, tip data set, total bill, and we can have tips. Tip, and the data set is called tips. Let's run it. Let's wait a bit and see what prints out. Yeah, see this? Amazing, right? It judged all of the data set present in total bill versus tips. It judged all of the data set, and ultimately it found out the best possible line that represents your entire data. You can even have hue here, let's have hue. The male and female, what portion of the male and what portion of the female here. It will separately have two lines for male and female, judging the male portion of the dataset and female portion of the dataset. It is a cool feature, amazing feature of Seaborn. For this type of features, it is mostly used. Okay, and the graphs also look amazing. Clear? Got it? You can do the same thing. The same thing with another function called a rag plot. Rag representing regression, and it will print out the same thing. What's wrong here? Hue. Okay, we can't have hue in rag plot. Okay, let's delete that. And you have a wonderful line. The same thing, the same thing. Okay, since our previous LM plot covered the hue, I think we can use LM plot more. So we are clear on the regression plot. Okay? Okay, fine. Another thing left for me to discuss, it is multi-plot. Okay? Multi-plot. We are gonna be creating multiple plots in one canvas. Previously we could do that how? We could do that like this. Let me show you. Like this. Let's see, we are building a scatter plot. Scatter plot. Let's run it. Okay. And we can do another thing. Write another plot code in the bottom of it. Let's say count plot, and count the number of let's say what number of male or female. Let's see if it runs. Okay, it overdue. Okay. Okay, the basically if you want to run two plots, multiple plots in SNS, you have something called pair grid. Let me show you that. I think it will be easier to understand rather than going like this. You can do something called, let's say G equals SNS pair grid. Pair grid, the P is greater and the G is greater. Mind it, guys. Now what's wrong? We have to put in the arguments as well. Okay, let me say I forgot the argument. Where can I find it? We can go to what? Our documentation. Let's go to our documentation, see that from here. It will take too much time, so let's see the documentation itself. Pair grid. So by using something called pair grid and inputting the data, we will find all the data we can build. So let's input it since it is only one parameter. Basically what it is doing, it is building the number of plots that will be required to correlate the numerical values. So here we have only how many? 3 numerical values. That's why we are having 3 by 3 matrix like plots. In total 9 plots. So we can relate all the numerical values with each other. That is correlation. Okay. After creating that, we can map that manually. Call something called map and do, let's see the code here, and mention what type of plot we want. Let's say we want sns.scatter. Let's see what does that do. You manually map it. Okay, scatter plot, it should be scatter plot. Remember that, guys, be very careful about it. Where are we? Yeah, let's run it now. Let's see what it prints. Okay, we are having a little bit trouble, so let's go to the documentation. Here you can see in gmap it is mentioning what type of plot we are gonna use, and it is automatically generating it. Another thing that I want to mention, you can do a bit manual stuff as well, like mapping it the upper portion of the entire matrix will be the definite type of plot. Here the upper portion is scatter plot, the lower portion is kde plot, and the diagonal is also kde plot. Here you can see it. Okay, this is also a kernel distribution, a type of kernel distribution. Okay, fine. Okay, one thing left for me to discuss. Rather than doing all of this manually, you can just do it like this, something called pair plot. Just input your data and it will automatically correlate every possible numerical features with each other and give you a correlation table. Let me zoom out a bit so you can have a proper view. See this, guys? 9 plots covering all of the numerical features and correlating with each and every one. See this? Fine? Okay. So let's see our agenda for today. If I have covered everything that is supposed to be covered, let's see that. Let's go to our discussion part. Yeah. Okay. Okay. We have covered what is Seaborn. We have told it is a Python library for data visualization. We have discussed why Seaborn. It is easier, it is more static, it is more popular. We have discussed in Seaborn there are two types of functions, that is figure function and functional function, you can say. In figure function you only change what? The kind parameter and draw different kind of plots. Then we have imported Seaborn as SNS. Then we have loaded dataset. We have loaded two dataset. One is tips and the other one was flight. Okay, and we saw where we can find all of the name of the data sets as well. We have discussed type of the plots, relational, distribution, categorical, matrix, and regression. We have discussed which for what, right? And then discussed plots regarding each of the use cases, each of the types. Like in relational, there's scatter, there's line plot, there's rel plot. In distribution, there's dist, hist, kde, and another figure level interface function, this. Similarly, in categorical count, box, violin, rug plot, in even another what figure level interface function, that is cat plot. In matrix we have discussed heat map. I couldn't discuss the cluster map, and it is a huge topic, another topic. Please search a bit. Okay. And in regression we have discussed LM and rag plot. Okay, fine guys. Okay, this was the flow. I have shown you everything. Okay. Okay, fine, fine, fine. Okay. Another thing to show you is that you can tweak how much you can tweak in each with each of the plots. Okay, let me just show you that, and we will have everything completed. Go to the documentation, go to the API, and scroll down. You will find this thing called theming, and in theming you will find everything there is related to changing your plot, coloring your plot, having this and that regarding your plot. Everything is mentioned here: set theme, access style, color palettes. Remember cmap you used viridis, we used magma. Go to this, have a look, you will find all the other options as well. Okay, palette widgets, everything. Okay, so you can do lots of theming by yourself manually. You can do lots of theming by yourself manually. So yeah, it was a quite the session, guys. I've covered lots of things. Here you can see lots of things covered, zooming out and zooming out and zooming out. So this was our lecture for a data visualization library called Seaborn. Seaborn. It was the second library for our discussion in data visualization. Tomorrow we are going to be discussing what? We are going to be discussing something called Plotly. You know why you are going to discuss Plotly? Because the graph is going to talk with us. See you tomorrow. Adios, guys.